forgot about the old charger. Here, people. Charger up. I had that on my mind and I didn't get it. Alright. Okay, here we go. There it is, all charged up. There's not, or it's charging. Alright, what did I say I was going to do here? Mr. Trig one, right? Good old trigonometry. So, number 4, everyone. Let's see what we got here. Number 4. Find the derivative. Okay. Let's see here. All right. Take the derivative of both sides, right? D dx, both sides. Another slurpy. So d dx of 2y is going to equal d dx of x squared plus, here we go, d dx sine of y. Oh boy. Trig, huh? Coming back. Slurpy. Alright, derivative of 2y here, people, is 2 times the derivative of the inside is dy dx, right? Is going to equal the derivative of x squared is 2x times, the derivative of the inside, but the derivative, remember, of x is 1. Plus now, here we go. Sine of y. You got to remember what the derivative of sine is, people. Do you remember? The derivative of sine is cosine. Remember that? Cosine? And also you need to remember here, people, if it was like the sine, of x squared plus 4, let's say, right? Remember that? Derivative of the outside evaluated at the inside multiplied by the derivative of the inside. Remember that? There's a chain rule, people. Right? Gotta do a chain here. Sine, right? The sine of y. Derivative of the outside. Derivative of sine is cosine. Evaluated at the inside. Cosine of y times now by the derivative of the inside. The derivative of y, right? dy dx. That's what we got here, people. Okay. So let's see. So I am Normally I would rewrite this and clean it up a little bit, but I'm worried about space, so I'm gonna just put cosine y and then dy dx there. Remember, we need to get all of the dy dx terms onto one side, you know. So I'm going to move that cosine y dy dx over to the left side by subtracting cosine y dy dx to both sides. All right, remember that's all one term. I cross out. So I'm going to have 2 dy dx minus cosine of a y dy dx is going to equal 2x. Yeah. Let me factor out a dy dx here. All right, I'll bring it over here. Factor out a dy dx. And I have 2 minus cosine y left over, right? Is going to equal 2x. Then, I'm going to divide both terms, right, by the 2 minus cosine y. Remember, we're looking to isolate for dy dx. All right, so divide by 2 minus cosine y. And there we go. Those guys cross out. I have dy dx here is going to equal 2x over 2 minus cosine of y. And there you go. That's your derivative. Right. All right, so let's see here. I said I was gonna do some on the next page. I don't know here. I don't think I'm going to do all of these, right? We should be getting the hang of this, I'm hoping. So let's see. Am I gonna do 5, 6, or 7? Might be 7, right? Let's do it. All right, let's do it here, people. Number 7. Page 3. Find dy dx. Taking the derivative of both sides. Right? So, there's going to be a little bit more work to this one, as you can tell. But it's all the same process. Got to take the derivative of x squared y, x squared times y, right? Plus the derivative of 3x times y cubed minus the derivative of x is going to equal the derivative of 3. All right, so, the derivative of x is not bad, right? The derivative of 3 is not bad. We know that 0. It's just the first two terms going to be a little annoying, right? In getting the derivative. Right, the derivative of 3 is 0. minus derivative of x, right? Minus 1. And here we go now. I'll start with the x squared y. Right? X squared times y. That derivative is a product rule. Same with that, 3x times y cubed. That's a product rule for both. First times the derivative of the second, right? Let's do it. All right, so the x squared y, the first times the derivative of the second. Derivative of y is a dy dx, plus the second, y, times the derivative of the first. Derivative of x squared is a 2x. All right, plus now we got to do the derivative of a 3x times y cubed. So, with that constant, with that coefficient of 3, I don't what do you want to do with that? Do you want to keep it on the outside? Do you want to put it with the x? Do you want to put it with the y cubed? I mean, it's up to you. I'm feeling like putting the 3 with the x today. All right, so 3x is going to be like my u. And y cubed is going to be my v. So the first, so plus now, right? Bring that down. Plus the first, 3x, times the derivative of the second. The derivative of y cubed is a 3 y squared, right? Times the derivative of the inside, eh? dy dx plus the second, y cubed, times the derivative of the first. The derivative of 3x is 3. Right? We don't put a dy dx there, right, with the y cubed and the 3, because we're not taking the derivative of y cubed. So remember what I said last time, you put a dy dx with a y when you're finding the derivative. If you're finding the derivative of that term and there's a y there, you slap on a dy dx. Not when you're taking the, you don't slap on a dy dx when you're not taking the derivative of y cubed, of a y. All right, so I am definitely going to clean this one up here. This is going to be x squared dy dx plus y times 2 times x plus 2xy plus 3x times 3y squared is going to be a 9 times the dy dx, 9xy squared dy dx plus 3y cubed, right? Here's the work now, right? Minus 1 equals 0. All right. So non-dy dx terms, I mean, you could technically move the dy dx terms over to the other side if you want to. Just out of habit for me, I always move the non-dy dx terms over to the other side. So minus 2xy minus 3y squared plus 1. Right, minus 3y cubed plus 1 to both sides, right? That goes, right? That'll go. I'll have now x squared dy dx plus 9x squared dy dx equals negative 2xy minus 3y cubed plus 1. All right, and here we go again. Factor out the dy dx from both terms here. That'll be x squared plus 9xy squared as your remaining factor. Right, and then we'll divide both sides here by that remaining factor to isolate for dy dx. And cross out. And I will bring the answer up here. Say that dy dx is equal to negative 2xy minus 3y cubed plus 1 over x squared plus 9x y squared. Right, and there you go. That's your derivative. Like I said, you want to move the the dy dx terms if you wanted to over to the other side because it was, 2 terms instead of 3 terms. You could have done that. Right? It's just, you would have, the numerator of our answer here, the signs would be different, right? It would be positive 2xy plus 3y cubed minus 1. And then the x squared and the 9xy squared would be negative. It's fine. It's the same thing. Over negative x squared minus 9xy squared.